So let's talk about hypersensitivity reactions. So there's going to be 4 hypersensitivity reactions. There's going to be 4, so type 1, type 2, type 3, and type 4. Type 1 through 3 all have a commonality, as in they use immunoglobulins, so antibodies. This is going to be an important concept. While type 4 is not going to use immunoglobulins or antibodies, and thus it's going to be cell-mediated. I'll explain what that means later. Mediators, that's not even a word. Cell-mediated. So let's cover these 4 types. So we're going to start with type 1 to begin. Type 1 hypersensitivity. So what is type 1 hypersensitivity? Well, it's going to be antibody mediated. So like I said, it is going to use antibodies. So how is it going to use antibodies? Well, let's take a look at a cell. Here we've got a mast cell, and or it could be a basophil, typically used interchangeably. So we've got a mast cell, and we've got an Fc receptor. We've got the Fc region of an immunoglobulin. And here's our FAB. The FAB portion, the FAB portion, is going to bind the antigen, while the Fc is going to bind the Fc receptor. So we've got this mast cell here. We've got a whole bunch of antigen that gets introduced. So let's say some ragweed in the air. The ragweed in the air goes into our nose, and the antigen is presented to the cells. So our antigen is presented and gets into our bloodstream. Once in our bloodstream, it will bind the IgE. So this is going to be an IgE specific immunoglobulin. It's going to bind that IgE. It's going to cause this mast cell to degranulate. And when the mast cell degranulates, it's going to release a whole bunch of histamine. So histamine release. Alright, so histamine. And histamine is going to be a vasoactive molecule. It's going to cause vasodilation. It can lead to shock in extreme cases or anaphylaxis. So some of the type 1 hypersensitivity reactions are going to be allergies, it could be anaphylaxis, and then also like atopy. These are all mediated by type 1 hypersensitivities. So just to recount, this antigen is going to bind to the IgE immunoglobulin, which is going to be located on mast cells after initial exposure. And this is going to cause the mast cell hypersensitivity. It's going to cause this mast cell to release massive amounts of histamine, and thus it is going to be antibody mediated. So the buzzwords for this, we've got allergies, we've got anaphylaxis, and we've got atopy. We've got immune system gone wild. We can use this for all of them. Immune system gone wild. It's kind of like the science version of those movies, just the immune system gone wild. Alright, so hypersensitivity reactions are abnormal immune reactions. So type 1 hypersensitivity should not happen. The body did not mean for this to happen. However, some antigens out there can cause this mast cell, so ragweed or pollen would be a good one. Certain foods like peanut allergies or any kind of food allergies typically are mediated by the type 1 hypersensitivity. Alright, I think I've beat that one to death. Let's move on to type 2 hypersensitivity. Scribble. Alright, so you've got type 2 hypersensitivity. What is a type 2? Well, it's going to be an antibody mediated. So what does that even mean? Antibody mediated. So like type 1, we're going to have antibodies somehow involved. However, this one, it's going to be where antibodies bind antigen on a cell surface. So let's draw a theoretical cell here. Let's just say it is a let's get a good thyroid cell. That's as technical as I need to get. So we have the thyroid cell. Then along comes, so it's got antigen on its cell surface, a whole bunch of antigen. Typically, I mean, this is normal. Of course, these thyroid cells will have some antigen. Every cell has some sort of antigen or some kind of marker that distinguishes it as a thyroid cell. So everything has antigens. So let's take this thyroid cell. Along comes an antibody. If I can draw it, there's an antibody. It's going to attach to here. So now we have, I don't want to draw it again, so it's now attached. And this is not normal because the body shouldn't be attacking our thyroid cells. However, our body is now producing, we've got B cells that are producing these antibodies against our own antigens. So this is not good. Antibody binds antigen on a cell surface. So here's the surface of the cell, here's our antibody. Typically we're going to be talking about IgM and IgG in this situation. And what's going to happen is once this antibody binds, it can either opsonize the cell, so that's one of the functions of the antibody is opsonization. It could neutralize the cell, or it could cause complement cascade, and then you get the membrane attack complex, destroy the cell. So the net result is pretty much going to be this cell gets knocked out. It becomes non-functional in some way because our immune system attacks it by producing antibodies. So it is still antibody mediated. So this is going to be the type 2 reaction. So what kind of diseases do we see? Well, we see myasthenia gravis. Myasthenia gravis is going to be autoantibodies. So autoantibodies that our B cells are making against the nicotinic acetylcholine receptors. So our nicotinic acetylcholine receptors, you'll see those on like the neuromuscular plates. I mean, so our muscles get affected. You have weak muscles because we don't have a problem making ACH. Our ACH production is fine. Acetylcholine is just a neurotransmitter. However, acetylcholine gets released into the synaptic cleft. It has nowhere to go because our receptors, our nicotinic acetylcholine receptors, are being attacked by our antibodies. Okay, so that's myasthenia gravis. That's one type. There's Graves' disease. I put this as a thyroid cell for a reason. Graves' disease, hopefully that connects. It's where you have autoantibodies against the thyroid. Then you have good pastures. Good pastures, if you can, EURS, I believe. And this is where you have autoantibodies against the kidney basement membrane. Good pastures is type 2. We also have hemolytic anemia. Hemolytic anemia. This is going to be where you have a destruction of the red blood cells due to the antibody. And then finally, you have, not finally, I have a couple more examples. I can think of rheumatic fever. Rheumatic fever is going to be where you have molecular mimicry. You have a disease, you have a strep disease come in, and then your body creates antibodies against that strep microbe. So you have a microbe that gets introduced. So here's your microbe. Your body is now producing antibodies against that microbe. Well, in rheumatic fever, what happens is these antibodies that you just created for this little microbe go to your heart, and they cross-react with an antigen that kind of looks like that microbe, but it's found in your heart normally, and it should be on your heart. So this antibody is going to think, I'm seeing more microbe, and it's going to attack parts of the heart, and that's what rheumatic fever is. And then also we've got erythroblastosis Fetalis. Erythroblastosis Fetalis. I think I spelled that right. Spelling's not my strong point, but we've got Erythroblastosis Fetalis. And what this is, it's also known as hemolytic disease of the newborn. And the number one cause for this is going to be Rh incompatibility. Important concept. So it's where you have an Rh negative mother, and so your mother. Let's see if I can draw it down here. Mom. It's going to be Rh negative. The baby. So on her first birth, on her first pregnancy, when she's giving birth, some of the fetal blood mixes with maternal blood, and your maternal blood senses. So let's see. Kid. We'll write kid. If I can spell this. K-I-D. Okay, I did pass kindergarten. So there's kid. Kid is going to be Rh positive. So what does this mean? The kid is going to have an Rh antigen on the surface of its red blood cells. It is going to be Rh positive. So when you hear that, it's meaning it has an Rh factor. The mother, however, does not. So when the blood mixes, the Rh factor is going to present to the mother's bloodstream, and the mother is going to make antibodies against the Rh factor. So when a second kid comes along, the mother during birth may have antibodies against Rh factors. So that way, during birth, you don't want to present this Rh factor again to a second Rh positive kid because the mother already has antibodies formed. So this is, maybe I'll make a video on that because that wasn't very clear. However, just know that Erythroblastosis Fetalis has a type 2 hypersensitivity. So now let's talk about type 3. So we have type 3 hypersensitivity. When you think type 3, it's still antibody mediated. Antibody mediated. Alright, so like I said, the first three, type 1, type 2, and type 3, all antibody mediated. However, this one, I want you to think complex. So you've got an immune complex. And what that is it's a formation of an immunoglobulin, so it's our antibody, and an antigen. And they form a complex, an immune complex, and what that does is it's going to lodge somewhere. So this immune complex will end up somewhere, whether it's a blood vessel, a basement membrane, wherever it lands, it's going to stick. So once it sticks, it's going to increase complement. It's going to stimulate, man, that's bad spelling. It's going to start complement. And what that is going to do is it's going to cause neutrophils to come in. It's going to cause the cellular debris, the membrane attack complex, are going to have localized destruction. So the neutrophils come in, they release cytokines, they're going to have localized destruction wherever this immune complex lands. So we've got some examples. Let's see if I can change color just to make it at least kind of interesting, because this is pretty boring stuff. So you've got serum sickness. So you've got serum sickness. Well, what is serum sickness? Look at that beauty. Okay, serum sickness is going to be a type 3 reaction to drugs, or like its name suggests, to serum. That's how it originally presented. Not sure. Oh, it's because I'm erasing. All right, lost an E. Serum sickness. It can be caused by drugs. It can be caused by serum, like the name suggests. Or, I mean, it can be caused by a couple other things. These are the big ones. It's where you have immune complexes. So your antigen in this process is going to be a drug, or it could be something that's found in the serum. And then you're going to have immune complexes formed, which will increase destruction wherever that immune complex lands. So serum sickness is one of them. Then you've got the Arthus reaction. So the Arthus reaction is going to be number 2. And there are more than what I'm presenting. I'm just touching on the main stuff. I like to focus on the main stuff. There are details that I always leave out. So what's going to happen in an Arthus reaction is you're going to think intradermal injection. So why do I say intradermal injection? You're going to have a localized shot somewhere. And what's going to happen is you're going to have antibodies that form against whatever was in that shot, in that injection. It's going to form a complex. That complex is going to locally deposit. So whether it's in blood vessels or the local tissue. And what you're going to have is you could have like a vasculitis, you could have an inflammation around your shot location, or you could have tissue necrosis depending on the level of complex formation and the amount of antibody and antigen present. So that's the Arthus reaction. Think intradermal injection, so at the localized site of injection. Then lastly, we've got a couple other like list of things. So we can do systemic lupus, we can do rheumatoid arthritis. These are all type 3 hypersensitivities dealing with complexes. You've got post-strep glomerulonephritis, hopefully you can remember the rest, glomerulonephritis. Then also like farmer's lung, you'll see like a hypersensitivity pneumonitis. I'm just going to write farmer. So farmer's lung, which is just simply a hypersensitivity pneumonitis. So these are all immune complexes. Then finally, let's get to the last one, type 4 hypersensitivity. So what makes type 4 special? Well, type 4 is going to be cell mediated. There are no antibodies, so it's going to be cell mediated. So what does that even mean? Well, we've got two types of cells. You've got T cells and you've got B cells that we're going to be concerned about. We've been dealing with B cells a lot, and that's because they secrete antibodies. However, in type 4 hypersensitivity, it's also known as delayed type hypersensitivity. So delayed type hypersensitivity, typically we're talking 1 to 3 days. So what we're going to do is we're going to have a presentation of antigen. So we're going to have antigen. What we're going to do is we're going to have increased cell response, and then we're going to have reaction. So that's the basic outline of what happens, and I'll kind of talk through it. Let's change colors just to keep you on the edge of your seat. Okay, so we've got T cells. We're going to be focusing on T cells, and of the T cells, we've got cytotoxic T lymphocytes, and we've got T helper cells. So for type 4 hypersensitivity, what we're going to do is we're going to talk about the T helpers first. It's where you have MHC, so the major histocompatibility complex, or the major histocompatibility structures are going to be like on antigen presenting cells, for example. And what's going to happen is they're going to present an antigen, and this T helper is going to bind to that antigen presenting cell, recognize that an antigen that's like a foreign antigen is being presented, and these TH helper cells will release interleukin 2 and specifically interferon gamma. So interferon gamma is going to be a big one, and what this is going to do is this is in turn going to increase macrophage work, and I'm pretty much increasing your immune system. So we're going to have an antigen. Let's see if I can draw this out. We're going to have an antigen APC, antigen PC, antigen presenting cell. And it's going to have a major histocompatibility complex, so MHC2, since we're on an antigen presenting cell. And what this is going to do is this is going to find a T helper cell, and they're going to recognize each other. So major histocompatibility 2 complex always binds with CD4. CD4 is going to be your cell surface marker for the T helper cell. So your CD4, MHC2, recognize you have some co-stimulatory molecules as well, like a C27, B7 binding. And what's going to happen is this T helper cell will activate. So now we have increased activated T helper cell. What this is going to do in turn is it's going to go find something else. So it's going to find, let's say, a macrophage. So we've got our T helper cell. Here's our macrophage. This T helper cell is going to give the macrophage a boost. It's going to release some interferon gamma and some IL-2. What this is going to do is it's going to make the macrophage a super macrophage, stimulating that macrophage to do overtime work. And that's just an example of the T helper cell response. Also, type 4, you're going to have an antigen, and it's just going to directly stimulate cytotoxic T lymphocytes to directly kill cells. So if a cell is presenting some antigen that is foreign and the cytotoxic T's don't like it, they're just going to kill the cell. Enough said, enough done. Alright, so ran out of room, so type 4 continued, if you're following along still. Alright, so what are some type 4 reactions? Well, our list is pretty long, but there are a couple hallmark or prototypical type 4 reaction things that test writers love. So one of them is going to be the Ppd test. So you're thinking to yourself, Ppd, I've heard that before. It's because it's for tuberculosis. That's your tuberculosis skin test. So if you work in the healthcare field or if you work pretty much anywhere, they often require you for a Ppd skin test. And what this is doing is you're checking for a type 4 hypersensitivity reaction. If you are TB positive, then you'll have a positive Ppd test. You're going to have the antigen present in the body, and this is going to cause a positive reaction. So if you're infected, you're going to have antibodies. You're going to have antibodies against TB. Alright, if you have antibodies against TB, you're going to introduce some TB antigen. So that's what the Ppd test actually does, is it's injecting a small minute amount of TB antigen into your skin subcutaneously. So if you have antibodies already preformed, since you already have a TB infection, they're going to react to that antigen that you just presented it with in that shot, and you're going to get the reaction. You're going to get the local destruction. Your cytotoxic T cells will come in. You're going to release some interferon gamma from the T helper cell. You're going to stimulate macrophages. They're going to release a whole bunch of nasty chemicals at that site, giving you the red little wheel that you'll see underneath the skin. So that's going to be your Ppd test. I can't keep at this pace, otherwise I'll run out of space. Let's kind of see if I can get rid of that. Okay. So Ppd test. What else do we have? We have type 1 diabetes, where you have destruction of your beta cells in the islet of Langerhans within your pancreas. We've also got graft versus host disease. Lung subject, I won't cover that because I know that I'm already going a little late. We've got multiple sclerosis. So myasthenia gravis is going to be a type 2. Multiple sclerosis is going to be a type 4. We've also got Guillain-Barré syndrome. Guillain-Barré syndrome, which is going to be like the peripheral demyelination. And then also you can get contact dermatitis. So if I had to memorize any, it would be these two, contact dermatitis / Ppd. These are the two main ones that they like to test on at any level. So type 4 hypersensitivity. What is contact dermatitis? It's going to be like poison ivy. So if you've ever had poison ivy before, my type 4 hypersensitivity to poison ivy is ridiculous. You can just waft some poison ivy next to me, and the next day, 2 days later, my skin will be destroyed. It's bad. But what happens is you're going to have your antigen, which is going to be the oil from the poison ivy leaf, and that's going to cause the type 4 hypersensitivity. Not dealing with antibodies at all, you're going to have cellular destruction due to those T cells. Alright, so this is it for the type 4 hypersensitivities. If you have any questions, be sure to ask. I always enjoy comments, so be sure to comment. And if you enjoyed this, please click like. I would appreciate that, and then subscribe if you want more great videos. Thank you very much for your time and attention today.